how do we solve for x given 1 to the power x equals to 5? Okay, so solution. Now we all know that when we have something to the power x equals to something and you ask to solve for this, what will come to your mind is to take log on both sides. That would be log 1 to the power x equals to log 5. So which will be, so this one is a power rule, that will be x log 1 equals to log 5. So from here, we divide both sides by log 1, log 1. So this one will go. So we have log 5 on log 1, but remember log 1 is equal to 0. So we have log 5 over 0. So this one will be undefined. It means this approach is not acceptable, okay? All right, so let's see how we can solve for this, okay? Now, what we are going to do here is to use the Euler's formula or Euler's identity. So which says e raised to I theta the same as cos theta plus I sine theta. We have the real part, then the imaginary part. Now let's prove this one. Okay, now let's let theta equal to 0 and see what happens. Now let theta equals to 0. Now once I plug in 0 here, this side will be I times 0. And this side will be cos 0 plus I sine 0. Okay, so I times 0 will be e to the power 0. And this side cos 0 is 1. And I sine 0 is also 0. And in a 0 number to the power 0 is 1. So we have 1 equals to 1. Hence proved. So this one is perfect. Okay, so once 1 equals to 1, it means perfect. Okay, now to continue, we want to represent theta by, so let's let theta be 2 pi k or 2k pi. 2k pi, where k is an integer. Okay, all right, so we have theta as 2k pi. So there's the formula. So in place of theta, I'll put 2k pi there. So we have e raised to I 2k pi. Let me write it well. I 2k pi equals to cos 2k pi, okay, plus I sine 2k pi. So since k is an integer, so k will be 1, 2, 3, 4 up to infinity. Now, what we are doing here is very simple. Because solving with this is not possible, we want to do substitution. And we want to prove, okay, we want to prove that this one will give us 1. So that is the idea. So let's start with when k is equals to 1. Now, when k is equals to 1, I'll do substitution. That will be e raised to I. So 2 times 1 is 2. That will be 2 pi equals to cos 2 times 1 is 2. That is 2 pi plus I sine. So 2 times 1 is 2, have 2 pi. So when we check cos 2 pi, this side is 1, and sine 2 pi is 0. So we have e raised to I 2 pi equals to 1. Therefore, the result is 1. It means e raised to this equals to 1. Everything here will be 1. Okay, now let's go to 1k equals to 2. We want to understand this one. So 1k equals to 2, this side will be 2 times 2. That will be e raised I 4 pi equals to cos 4 pi plus I sine 4 pi. Now, in terms of periods, so 2 pi and 4 pi, they are in the same period. Therefore, this one is the same as that. Okay, so cos 2 pi and cos 4 pi is the same. So we have 1, and this side 2 is the same, 0. So e raised to I 4 pi. So 1. Therefore, everything is 1. Okay, so let's try the last one. Okay, for 1k equals to 3, I'll do substitution. I'll put 3 here, so that will be 6 pi. So we have e raised to I 6 pi equals to cos. So 6 pi plus I sine 6 pi. So same thing, they are in the same period. This side is 1, this side to the same period is 0. So e raised to I 6 pi. Okay, therefore everything is 1. So in short, e raised to I 2k pi is the same as 1. Okay, so now the question is solved. So we conclude that e raised to I 2k pi equals to 1. Okay, so we have the question as 1 to the power x equals to 5, 1 to the power x equals to 5. So this is 1, this is 1. So in place of 1, I will do substitution. That will be e raised to I 2k pi equals to 5. All right, so from here, we can solve for, x, everything to the power x. So this is 1, this 1, so to the power x. Okay, so from here, we can take log on both sides. That would be log, okay? Or we can use ln. So we have ln of that, e raised to I 2k pi x. So have multiply everything equals to ln of 5. So this one is a power rule. That will be I 2k pi x. Then write it for I 2k pi x, okay, times ln of e, okay. So we have this e equals to ln of 5. Remember, ln of e is 1. So that would be 1, 2k pi x equals to ln of 5. So from here, we can divide both sides by I2k pi I2k pi. So this one will go. My x is ln of 5 on I2k pi. All right. So subscribe for more exciting videos like this. All right.